Question number 12. This is the function given and the domain is x greater than a, and the part A we want to find the A that f inverse x exists. So basically to have a one to function, inverse function for a function, the function should be, or fx should be 1 to 1. Now when you look at this graph, this is a quadratic graph. And this is not x and y axis. Yeah, this is x axis. This is not y axis. This is the symmetric line. And when you look at, so this is, if you select y equal, let's say p is a constant, and we have two x values, x equal a, x equal b, for both a and b from domain. It has one value for range. Let me change this x equal a, because a, they all a. I will take, this is t, x equal t and m. So when you put t value, the y value is going to be p, and m value also, y value is p, because the coordinate is tp, mp and tp. Now this is many to one, so this is not 1 to 1. Now how you can find the f inverse x for this function, because it's a many to one. But you can alter this function using the right domain. Then we can make 1 to 1, and then we can find f inverse x. Now we have two options to make 1 to 1. One is left side. The other one is right side. Here also, if you select, this is x equal alpha, so x less than alpha also 1 to 1, x greater than alpha also 1 to 1, because for one x value, one y value, one x value, y value. So x equal alpha is the symmetric line. So this is the minimum point, basically alpha and the y value. So we'll find the minimum value, that is y complete in square, x square plus 6x minus 4, that is x plus 3 square minus 9 minus 4, x plus 3 square minus 13. So x plus 3 equals 0, x equal minus 3. So this is minus 3, and y value is minus 13. So basically x equal minus 3 is the symmetric line. So if less than minus 3 or x greater than minus 3, the function is 1 to 1. But we have to select this one, because the sum is given x greater than value, not less than. So in that case, we must delete the left side of the graph. Basically, this is not the graph we need. This is the graph. Hence, least value of the graph is least value of the graph is x equal minus 3. Hence, when x greater than minus 3, the function is 1 to 1. Hence, a equal minus 3. Part B. Now the sum is given that a equals 0. When you look at the number line, so minus 3 is here, 0 is here, then it's definitely 1 to 1, because from this point onwards the function is 1 to 1. So a equals 0, 1, 2, 3, any number you can pick up. Now instead of getting x equal minus 3 bottom, so we want to think about the area where the graph is. We'll try to draw properly and let's see. Symmetric line is x equal minus 3 and y-axis, x-axis. So this is x equal minus 3 and the minimum one is minus 3 minus 13 we found out somewhere here. And let's see the y-intercepts when x equals 0, 0, 0, minus 4. So 0 minus 4 is so this is minus 4 value, 0 minus 4, and this is minus 3 minus 13. Now part B, a value is 0. It means we want to consider the graph from here. This is the part we need. So we don't want to bother this area. Now domain x greater than a. Now we take a equals 0, so x greater than 0. So this is the domain. So domain of fx. So what is the range? The range is going to be what is the minimum and maximum y value. So minimum is minus 4 and max is going to be infinity. So range is minus 4. I can't put equal sign because this is not equal to 0. The domain is not equal to 0. So minus and fx infinity. Or you can write minus 4 less than or fx. That's also right. So this is the range. Now we need to find the f inverse x domain. So f inverse x domain means that is the range of fx equal range of fx. So then minus 4 less than x. Sorry, minus 4 greater than x, or x should be greater than minus 4. Now we can find the function. Actually, we'll find the inverse function. So y equal x square plus 6x minus 4, y equal x plus 3 square minus 13, and y plus 13. So we want to make x as a subject, and then x plus 3 square. So x plus 3 square equal y plus 13. So x plus 3 equal y plus 13 square root, and x equal y plus 13 square root minus 3 plus 3 to other side. So then x goes to f inverse x and y goes to x. So f inverse x equal x plus 13 minus 3, and the domain is the range of, and the domain of n is the range of fx, which is minus 4 greater than or we'll write the other way around, x greater than minus 4. Question number 13. This is the fx and gx. We need to find part A, f inverse x, inverse function. So this is, I will write y equal 4x minus 1. This is a line. It means it's 1 to 1. So we can find the inverse function. So I'll make x as a subject, and then x uh, goes to f inverse x, and y become x. So this is f inverse x, and this is x plus 1 over 4. So this is the inverse function. And the domain is, what is the range of this one? So domain is given real numbers. So then the range also, it is a line. So when x goes to infinity, minus infinity, this is goes to minus infinity. X goes to positive infinity, y also goes to positive. So then minus infinity, y positive infinity. Or you can tell simply y is element of the range of this one. Range of is y is the element of real numbers. This is the range. So the domain is x. Instead of y, I put x. Is the element of real numbers. Part 2, we need to find part B, composite of G, F. It means G, F, X. So we write first of all Gx, 3 over 2x minus 1. Then instead of x, we replace with fx. G, fx equal 3 to fx minus 1. So 3 to fx, now we know that 4x minus 1 minus 1. So when we simplify this one, 3, 8x minus 2 minus 1, 3 over 8x minus 3. So domain for this function, you can see when x equal 8 over 3, 3 over 8 actually, this value becomes 0. So 3 over 0. It means the answer is go towards infinity. It means x equal 3 over 8 is asymptotic. Hence, the domain is for this function is x is an element of real numbers, but x can't be 3 over 8. Part C is 2fx equal gx. So 2 times fx is 4x minus 1 equal 3 over 2x minus 1. We have to solve this one. So cross multiply 2x minus 1 uh, 3. So we have to expand this one. 4x minus 1. I'll multiply by this one. So 4x minus 2 equal 3. So then 4x times 4x minus 2. I'm expanding from this bracket. So 4x times 4x minus 3. And then minus 1 times 4x minus, 2 equal 3. So instead of multiplying this one inside, I multiply by this one. So 2 times 2, 4x, 2 times minus 1, minus 2. So this is 16x square minus 8x. This is minus 4x plus 2 equal 3. So this is 16x square minus 12x minus 1 equal 0. So A equals 16, B equal minus 12, C is minus 1. So X equal minus B plus or minus B square minus 4AC over 2A minus minus 12 plus or minus B square minus 12 square 4 times A is 16 times minus 1 over 2 16. So 12 plus or minus 144 plus 64 over 32. This is going to be 12 plus or minus 208 over 32. So from calculator you can get two answers, minus 0.76 or 0. X equals 0.826. Question number 14. The effect is this gx is this one, and we want to find an inverse function for this one. So I'll take y equal x over x minus 2. We'll make x as a subject. So y times x minus 2 equal x. Then I want to take x one side, yx minus 2y equal x. So y x minus x equal 2y. So I can take x, I can factorize x, y minus 1 equal 2y, x equal 2y over y minus 1. And then x goes to f inverse x and y to x. The inverse function is 2x over x minus 1, and the domain is when x equal 1, it's asymptotic, so x is a real number, but x can't be equal to 1. Part B, we need to write the range of f inverse x. So range of f inverse x is the domain of fx. So domain of fx is this one. So instead of x, we write f inverse x element of R, and if inverse x, that value cannot be equal to 2. Part C, we want to calculate GF 1.5. So we can find f 1.5. So if 1.5 equal 1.5 mean 3 over 2, 3 over 2, 3 over 2 minus 2. So this is 3 over 2. So 1.5 minus 2 minus half, that is minus 1. 3 over 2 times minus 1 over 2 minus 3. So if 1.5 equal minus 3. Now G, instead of if 1.5, we can put G minus 3. So now G minus 3 we can find. We have Gx equal 3 over x. G minus 3 is 3 over minus 3, which is minus 1. So Gf 1.5 is minus 1. Part D, we have to calculate Gx equal fx plus 4. So Gx equal 3 over x, fx equal x over x minus 2 plus 4. I'm going to multiply this equation by x times x minus 2. So then x times x minus 2, 3 over x, x times x minus 2, x minus 2 plus 4 times x minus 2, which is cancel out. So 3 times x minus 2, this is cancel out, x square, plus this is 4x minus x minus 2. So 3x minus 6 equal x square, I'm expanding, 8x square minus 8x. So this is going to be 9x square, and minus 8x this 2, minus 11x, and minus 6 to other side, plus 6 equal 0. Actually 4x times x is 4x square, so it will make 5x square, because now we can simplify easily, I believe. So 5x square minus 11x plus 6 equals 0. 5x minus 6, x minus 1 equals 0. So 5x minus 6 equals 0, or x minus 1 equals 0. X equals 6 over 5, or x equals 1. Question number 15. This is a piecewise defined function. The division is x equals 0. So x is less than or equal to 0. This is the function. Nx equal 5 minus x, and x greater than 0. This is the function nx equal x square. So up to here line, and from here to here it is a quadratic function. I can see that part A, we want to find n equal minus 3. So whereas minus 3 lies, so this is 0. Minus 3 is here. Then this is the equation. So since x equal minus 3, let's refer nx equal 5 minus x. Then n minus 3 equal 5 minus 3, 5 plus 3, which is 8. Since n equal, we need to find n3. Since x equal 3, let's refer nx equal x square. So n3 equal 3 square, which is 9. And then part B, we want to solve nx equal 50. So this is a quadratic and this is a linear equation. So this is nx equal 50 line. So then we have to consider one is 50 and the second one is 50. So um, for x less than or equal to 0, or consider x less than or equal to 0, uh, 5 minus equal nx. So 5 minus x equal nx is given 50. 5 minus 50 equal x minus 45 equal x. One point is x 45 and the relevant y value is 50. So one intersection point. So consider x greater than 0. So 5x square equal nx. So x square equal 25, 50 given, and x equal plus or minus square root 50, x equal plus or minus 2 times 25, that is plus or minus 5 square root 2. Since x greater than 0, or x should be positive, hence x equal 5 square root 2.